Welcome everyone to DBT office hours. For those of you who are new joining, it's really nice if we can have some cameras on. For the presenters, it just feels like there's people on the other end of this call. Today we're doing a BigQuery special, and we're going to deep dive into a couple of different topics and then leave room at the end for anyone to ask any questions, particularly pertaining to using DBT and BigQuery together. And hopefully some other people in the community can help out, because I'm going to admit BigQuery is not actually my strong suit. The timing of this office hours was actually a coincidence, but today is BigQuery's 10th birthday. So we lined that up really well. So yeah, they're asking for people to wish them happy birthday on Twitter. So if that's your style, feel free to go ahead and do that. In terms of our topics today, we've got two different speakers. We have Claus, who's currently in LA, going to be talking about blue-green deploys on BigQuery, and Rasmus, who is in Europe, but I'm not sure which part of Europe, so we'll find out shortly. We'll be talking about using machine learning and BigQuery together. So I'm going to pass over to Claus first and let you take control of the screen. Oh, you're still muted.
There you go. Thank you. Classic problem here. I managed to put together a couple of slides, so hopefully this will help out here. And so my name is Claus Herther. I run a little consulting shop called Calogica. I have a few local clients here in LA. One of them right now is KWibi. For those of you who are in the US, you might have heard of KWibi. It's a mobile app for short form content, very sort of well-produced short form content for iOS and Android. I helped them put together their data warehouse using DBT before we even launched. This was quite tricky. We had a lot of test data, but we didn't have any real data. And so putting together a fully fleshed out data warehouse, including Looker, was quite a challenge and super fun to do. We launched on April 6th and have been enjoying the fruits of that since then, and had basically full analytics from day one. DBT was a huge part of that. We're pretty much 100% on Google Cloud. A lot of us were also new to BigQuery. We had some Snowflake experience, some DBT experience among the team, and some Looker experience, but many new technologies. And so one of the concerns we had early on, because of the makeup of the company and sort of culturally, we want to be very agile, but we also want to make sure that we don't have bad data coming into our dashboards. And so one of the big questions that we had early on, how do we keep from publishing bad data in dashboards? And so there's sort of a mix of balancing speed and agility. We want to be, we're a startup, we want to be fast with things, but we also have an audience that comes from entertainment that isn't really used to the sort of slight chaos that people in startups are used to. So we want to balance this with trust and adoption. We want to make sure that people trust these reports. Some people are new to being very data-driven. And so we explored various things. And so today I want to talk about using what we call the WAP pattern on Google BigQuery with DBT. We're going to talk about a little bit about blue-green deployment, tell you what that is, at least as far as I know. We'll talk about how WAP fits in there and what WAP is. A little bit about data warehouse SLAs, service level agreements. We'll talk about how to layer your DAG, how to do a custom schema based on a target and maybe even a variable. And then lastly, how to implement this with Airflow and DDT Cloud, either one. And so real quick on blue-green deployment. Martin Fowler is well known in the software community. He writes a lot about software development, software engineering. He defines this as blue-green deployment means that you deploy new code to a copy, which he calls green, of the production environment, which is blue. Then you test your code there in the green environment, and then when you're satisfied, you flip a switch, or he calls it a router, to the environment with the new code. So you guys can read on this link I posted about blue-green deployment. How this relates to data, in a data world, that is often implemented using what's called WAP. And WAP stands for Write, Audit, Publish. A lot of us at KWibi actually originally came from Netflix. And Netflix, a couple of years ago, I guess at this point, wrote a nice presentation, had a couple of YouTube videos on this, on scaling data quality at Netflix. And WAP is a big part of that. And the first step in WAP is that you write your data to a partition in an audit table. and then you test the audit table. And lastly, you swap that partition from the audit table with your prod table. They use a lot of Hive, and so swapping partitions is a common thing there. And so when you have something like WAP, really the worst thing that can happen with it is that your data warehouse becomes slightly stale, right? That's your downside protection here. And so to quote Mitch Hedberg here, escalators are never broken, they just become stairs. Sorry for the convenience. I stole that quote, or the inspiration for the quote, from my friend Scott Breitenother, who sort of rephrases this as: your data warehouse temporarily has data from the launch of a business through 2 days ago. Sorry for the convenience. I encourage you to read that article on data warehouse SLAs that I linked to down here. It's quite good about how to really talk to your community about what to expect when people create your data warehouse. And so how do we do WAP on BigQuery? Well, BigQuery doesn't really have partition swapping, right? And unlike Snowflake, BigQuery doesn't have zero-cost clones. So some of these ideas are kind of, at first, seem really hard to implement. And so what we decided at KWibi is that we're just gonna fake it. So one way to fake that on BigQuery, especially with DBT, it's actually quite nice. What we've done is we decided to implement it in the following steps, is that we use DBT to run a whole DAG into an audit schema or database. You can choose that. And then we audit that using DBT test. We audit the entire DAG in that audit schema. And then lastly, we publish it by running parts of the DAG again into the prod schema or database. And so it's a little bit extra, but that's how we chose to I guess, sort of fake it. And one way you can do that, and one thing that you have to do in order to even be able to do that, is to layer your DAG. And layering in general, I'm a big fan of in your DBT DAG, but in this particular case, you really want to be able to do that. And so layering your DAG means breaking up your DAG so you can selectively publish. And the way we structure projects typically is by breaking up our DAG into sort of logical layers. You can call these anything that you want, but the way that we sort of approach this is we have a staging layer, we have a transform layer, we have what we sort of collectively call the DW layer, and then what we call XA, and I get into what I mean by XA. But you can think of these things as the first 2 layers are private layers. That's where we do as data engineers, we do our work that we don't necessarily want to publish. And then DW onwards is what we consider to be public. And so we think of this almost like an API. You have public and private functions. Private functions are not something that the general query community needs to access. And so that way we can control that a little bit better. And so in your staging layer, and this is typically, this follows similar to things that Fishdown recommends. This is where we rename columns and we fix some data types. We don't do any transforms. In transform, we do all the complicated business logic. That's where we do all of the heavy transforms. So we do all of that in a private layer. And then in DW, that's where we actually simply take the transform models and we expose them as fact and dimension tables. And those are typically pretty lightweight transforms. We don't do a ton of stuff in there. It's really mostly selects from an upstream model. And then XA is sort of a term that I coined, extended aggregates. It's really a way for us to combine fact and dimension tables into more denormalized reporting tables. It's really great for Looker. It's great to build your explorers on. So these really for us are the source of all explorers in Looker. We call them extended aggregates because reporting tables is sort of it's not a great modern way of thinking about these things because they're not necessarily tied to a report. And so we like this term XA. It also happens to sort nicely when you look at this in your schema. It's nicely at the bottom, people can find it. And it's also fun to make people say that word XAs all the time. And so those are really also relatively lightweight joins and aggregations, but not heavy business logic. And then in terms of publishing this into schemas, the way I think about this during the audit phase, the stage layer is for us mostly ephemeral, so there's not really an impact here. But the transform layer during the audit phase goes in the transform schema, same as in production. The DW layer, where you have all your public fact and mention tables, during the audit phase goes in a schema that we call unaudited to make that clear that this is data that isn't yet audited. During the production run, this goes into the respective subject areas. So we use schemas or data sets in BigQuery polymers, we put them in specific subject area schemas. So we might have a playback data set, we might have a content data set, we might have a subscription data set. And then the XA tables during the audit run also go in unaudited because we don't want to publish them yet. But then during the production run, today we just put them in the XA schema, but you may choose to also put them in some custom schema. And we do that by simply doing a little override of the custom schema macro that a lot of you already use. Here in the fourth and fifth line, we simply say, hey, if the target name, in this case, we use target in our case, if the word audit is in the target name, then put it in the unaudited schema, unless it's a staging or transform table. And if the target name doesn't have the word audit in it, then simply put it in the custom schema. So there's, you know, 2-line addition to your custom schema macro. And you want to be able to test this locally. So quick way to really just do this locally is to set up a couple of different targets. So most of you have some sort of a dev target. This is your standard BigQuery connection. And then we simply add another target called dev audit. And so when we run this, it sees that, hey, the word audit is in there. And so it thinks of it as like, it's almost like a variable. And we do the same for production. You have your prod target, and then you have your prod audit target. And so putting this all together, we essentially do a first run where we target prod audit. This runs the whole DAG into prod audit. So the transform tables go in there in the transform schema, and all of the public tables go into the unaudited schema. And then we test that same way, just test those tables. Once that passes, we run again into prod schema, but only the models from the DW layer onwards. And so in our case, DW happened to be a folder in our DBT project, so it's easy to do the model selection this way. So anything that's in the DW folder and onwards, meaning all of our fact and dimension tables, all of our XA tables, end up getting rerun. And because they're not super heavy, we take a little bit extra processing time, a little bit extra bytes that are being built, but we want to take that, that's a cost we're willing to pay in order to get this extra level of safety for not publishing bad data. And then we're a little paranoid about this. We end up testing the prod deck again. And so my friend Josh Peng, who I don't know if he's on the call today, but he is also at KWibi right now. He's doing all of our data ops. He put this together over an Airflow, simple Airflow DAG. You can see how we do some source schema testing. We run the audit portion of it. We test the audit portion of it. We then run the public portions of it again. We have some custom data freshness stuff that we do. We test the prod portion of it again, and then we do some doc generation and serving. And so you can do that in Airflow. You can also do that real nicely in DDT Cloud. We, for some other reasons, happen to use Airflow, but DDT Cloud was definitely also on the menu. And so in this case, you can't use targets in DDT Cloud, I think. Claire can correct me there. Maybe that's coming. But at the time that I was working on this, you can really just pass a variable. And so if you notice there on the 5th line here, just extended that macro a little bit. Hey, if there is a global variable called audit and that's set to true, then we're in audit mode. And so send all of these things that are not in staging or transforming into the unaudited schema, otherwise use the custom schema. So pretty simple addition to this. And then you can implement that in DBT Cloud just like that. You pass in the variable, audit is true for the first 2 steps. And then the 3rd step, in this case, instead of DW, in this test project that I have, my public layer is just analysis and anything onward. And so at the end, I run the public portion again. The test project I have is this NFL test data that I happen to have on my DBT Cloud project. And so in this case, this is how this would look like. It runs everything successfully here. If the test step runs, then it will run the analysis portion of it, the public portion of it again. We can check that real quick. This is during the audit run. You see how these XA tables, and these are not really fact and dimension tables. These are just sort of, entities here. But everything gets run into the audit schema, so audit teams, audit plays. This field gold XA and fourth down XA goes all into audit, except the staging table here. This happens to be a physical table, goes into staging because that's private. I don't need to put that in audit. And then in the actual prod run, I'm only running the analysis tables again. but this time they go into the analysis schema. So it works out well nicely there. I happen to have not any new data here, so nothing's being merged, but that would work just fine. And so to wrap that up, what you want to do in order to implement WAP on BigQuery is layer your DAG into private and public layers. That's probably a good idea in general, so benefit there. You want to use a conditional schema macro to do that. Then you run the full DAG with the audit flag. Then you test the full DAG with the audit flag. And then lastly, you run the public layers of the DAG again into their respective part schemas. Excellent. And if you guys have any questions, open to that.
This is incredible. Yeah, if anyone has any questions, feel free to drop in the chat and then we'll quickly throw to you to ask that question. We'll just have a few minutes for questions now, and so that we can also have Rasmus present, and then we might have some more questions at the end. I wanted to start off with sort of an adjacent question to this. A while back, when I was chatting with you, you said that you had a line with BigQuery open about actually implementing a rename statement, which I think would make a lot of this potentially simpler. Did you happen to get any progress on that front?
No, I don't think so. I don't think we've heard anything yet on that. Whether this is partition swapping or any sort of schema renames, all of these things are currently still not happening.
Yeah.
We like BigQuery for many reasons. We've been really quite happy with the performance of it and in general with the usage of it. And so some of these niceties and sort of syntactic things there, currently we're willing to work with it. We do obviously add a little bit of processing time and building time here. But so far I have to say it's worth it, but you do have to be mindful not to do too much in that public layer, right? That you don't end up processing everything twice. And so just something to watch out for, but at least we're able to do it. And so like I said, with DBT, that was super easy to do, being able to conditionally send these things out, so that was huge.
Yeah. One other thing that I was just noticing when I had a look, when you had up your custom schema name macro, one other tool that I think you could leverage is like the node object, and the FQN part of that object is like the directories that a model actually is saved in. And so I saw like there was some logic around like, if this is in the schema called audit, then do this. But yeah, also potentially another way to solve this problem in terms of like automating that process of which schema does this go into is actually using the directory structure of your project to help drive that logic a little bit. So
yeah, that'd be awesome. Yeah, there's so many great ways to do that.
Yeah.
And I was surprised how easy this was. At first, this seemed like a big challenge to do. And then we're like, oh, wait, there's just a couple of things in DBT, done.
Yeah, really cool. Did anyone else have any questions?
There's a question in the chat. I'm
yeah.
just going to get to that now. Whether people have access to the private layers, DBT docs. Yes, they do. Is this currently, we're okay with that, people seeing it. The bigger problem is that people in theory actually have access to query this if they have BigQuery access, because it's not all that straightforward to do BigQuery permissions on a data set. And so we trust that the folks that have query access don't go there, but currently we're dealing with this by simply naming them in a way that sort of discourages people from using it. So, and we call the audit schema unaudited. So if you're querying something called unaudited, then you're kind of on your own here, right? And like data engineering is sort of the prefix there, so people know, okay, maybe I shouldn't be there. On the generate DBT docs Airflow task, I'm gonna have to defer you to Josh Peng, who every now and then hangs out in the DBT Slack channel. He's the Airflow god at KWibi. He's great there, but I don't know that much about it. And yes, if the tests fail in audit, it does prevent all tables from going to production. That's by design. We want that because the data warehouse really benefits from combining fact tables, right? This XA layer is where we take subscription data and playback data and all of these different things and combine them together. And so if playback data, for example, fails for some reason, we don't want Looker to have any new data. It's a little bit hard to be super selective then, very surgical. And so far we've decided basically that if something fails, we'll just deal with the fact that it's not updated. We do a lot of intraday runs. And so we have many more opportunities to fix something and let it rerun. If you're only doing one run a day, at night, then that gets tricky. And so you do have to experiment with that a little bit. That's a good point about new engineers. Well, now I have a presentation to give them when we have new engineers. That was very nice. Forcing function here. Thank you, Claire. and make them watch the Netflix presentation. But it's definitely a little bit of an education process. Many people that come from startups are not used to this. It's a little bit more process heavy than many startups. But when you come from a place like Netflix, you're probably used to that already.
We've got one last question, just to increase interactivity. John, do you want to ask your question? If you're available. If not, I'll just read it out. Cool. So what's the benefit of having fact and dimension tables in BigQuery? I thought it was more beneficial to have really wide tables.
Oh, that's a religious topic. This can be hours here. We like fact and dimension tables from a logical standpoint, right? They're nice building blocks. They're really great Lego blocks that we can then use to combine into many wide tables. So you're absolutely right, wide tables are great, but these XA tables, that's what we expose in Looker. So we do expose the wide tables in Looker. The XA table is essentially an explorer, and that has everything in it. So we largely denormalize dimensions out. We do take advantage of joins and explorers in Looker, just because it makes that easier for people to use. So there's always sort of a performance versus usability trade-off that you have to make. But from a design standpoint, if I have really cleanly designed fact and dimension tables, I can create all kinds of different XAs then. So we like that hybrid approach. It makes it easy to think about things versus having to, redo all of your big denormalized tables because you added a new fact or something like that.
Yeah. I could see Josh Andrews doing a celebration. Yeah, definitely like work with your data warehouse technology. Making sure that you're working with the most expensive resource of all, human brains.
Exactly.
Optimizing it for people. We've got one last question, and then we'll throw over to Rasmus to talk about machine learning on BigQuery. Sasma, are you able to unmute yourself and ask the question?
Hey, my name is actually Shahid, but that's my official /name. So anyway, so I have a question with respect to the stage layer. I have a setup which is very similar to what you kind of just walked through. But one question I've always kind of struggled with is do I want to add a filter when I'm selecting, say, data in my stage layer? The downside would be if I'm actually running my DAG in case of failure, then I would want to get in data more than just the last day. Essentially purely to minimize the data scan. Just curious to know what your thoughts are on this.
Yeah, I mean, DBT has really nice incremental processing capabilities, and to a large degree, we take advantage of that. They're obviously a little bit tricky, not because of DBT, but because date logic is tricky, and incremental processing is always a little bit trickier than just rerunning something. But we definitely, for our big fact tables, we run a few days, we reprocess a few days at a time every day. So we don't do the full reprocessing, we process the last, let's say, 2 days every time we run, just because we have later writing facts, which is pretty common. People on the app are offline, and so maybe they send some events later. And so we do reprocess some of this. By partitioning the tables correctly by date, right, you can take advantage of partition filtering there on BigQuery. And at the same time, also make sure that you're not missing data, right? So you have to, incremental processing is tricky. You have to experiment with what works for you, whether you do a full sort of, 2-day, 3-day, 4-day reprocessing, or you're very targeted about it. That depends on your data. But in this WAP pattern, we definitely take advantage of incremental processing.
Interesting. I kind of use the incremental just from, say, the transform layer. Didn't necessarily want to use it at stage. Maybe I'll give it a thought with respect to probably a wider date range. Thank you.
Yeah, one thing with BigQuery it's harder because you get charged by the byte, but normally it ends up also being faster sometimes as you do a full reprocess. And so it's hard to say one's better than the other, but you just have to experiment with what you're building there. We have the question on the insert override setting real quick. I think Jeremy is on the call someplace. We actually have started using the insert override, the new BigQuery functionality on one table, and it's been huge. So Jeremy, we were finally able to take advantage of it, and it was a big win. Been meaning to tell you that, because initially it didn't look like it. I had worked on this stuff a lot. But yeah, that stuff's great.
Cool.
Thank you. Thanks, everyone.
Excellent. Thank you so much, Klaus. That was incredible. From here, we're going to move to talk about some machine learning with Rasmus. So over to you.
Thank you very much, Claire. let me see if I can share my screen.
Cool. Just as you're getting prepared, so if you have a question for this part, feel free to throw in the chat, and then we'll try to throw to you to ask the question. I forgot to say this at the start, but if you can also just introduce yourself really quickly, that is just a nice vibe as well.
Yep. Yep. So my name is Rasmus. I live in Copenhagen, Denmark. I work at a newspaper here in Denmark, the 5th largest. It's called Kristeligt Dagblad. That's very hard to say if you're not Danish. But yeah, it's a 125-year-old newspaper, and we're been moving online over the past 15 years or so, and with that also as the new small data team has begun to rise. And since we're very small, I get to work with everything from data engineering to data science, machine learning, and DBT analytics in general. We've been experimenting on a very conceptual level with machine learning models managed through DBT. So training machine learning models using DBT and using them for inference as well. So I'll go through how we implemented this, and I'd love to hear if anybody has done anything similar or anybody has any good ideas that they'd like to share. We'll start out I'll just start out with showing you our high-level overview of our data infrastructure. I'm sure it looks a lot like most of you guys as well. We bring data into our BigQuery project using Airflow or directly through the BigQuery streaming API for event-level data. And then, like Claus also talked about, we have different sort of stages in our DBT project for raw staging and marts level data. And then we have our BI tool Periscope, who queries our final marts. On the side of that, we also use different machine learning frameworks in order to compute recommendations for users or to compute some propensities to convert and so on. We've been using BigQuery ML, but also other frameworks such as TensorFlow and scikit-learn. But this is all previously, this was all done outside of the data warehouse using some elastic compute on Kubernetes, for example, and everything was managed by Airflow. So it had a lot of infrastructure on top of what we're already maintaining inside BigQuery and inside our ingestion pipeline. What we also realized was that we would be using these models to do batch inference on larger data sets and then bring the results back into BigQuery for visualization or further processing. And we realized we had this loop where we bring data from our marts out to compute out of the data warehouse to train a machine learning model. And then we would effectively use this model and bring our data back into the data warehouse. So we thought we might be able to use DBT to move the entire batch training and inference part of machine learning back into the warehouse or inside the warehouse completely. So we tried to implement something like this where we take machine learning with BigQuery ML and maintain everything through DBT. We can still do inference outside of the warehouse because we can export models or we can use the API or whatever, but we can also reference models directly through DBT in downstream ordinary tables. Right. So we thought about implementing, or we did implement 3 features. Of course, a custom materialization. So instead of materializing your DBT model as a table or a view, you can materialize it as a model, a machine learning model. So I'm going to show you in a second, but this would basically say you set the config, to materialize this model, and then you write your SQL statement, which is just your input training data for your model. We also wanted to keep tabs on our our training information. How did the training process look like? Our features, which features are explaining variance and so on, and also our weights, so that we can keep an eye on this over time, especially if we want to retrain a model every week or every month or so. It's nice to have some history, so that we can make sure that our model is still performing over time. Finally, we implemented a wrapper around the predict function in BigQuery, so that we can easily call or use these models in downstream tables. We put all this in a package that we just kept locally in our DBT project, so it was nicely separated from everything else. And yeah, this is still very much specific to our needs, and there are a lot of features that aren't supported, but it's I think it's a pretty nice starting point. I'm just going to go through each of these different features. We'll start with the materialization. So here we have the DDL for a model in BigQuery. So instead of doing create table as a select statement, you would do create model, your model name, and a set of options. This is a logistic regression model, and you can set some parameters that are defined by BigQuery. And then finally, you select your training data. Now in DBT, we would do that like this. In our config, we set the materialization to model, and then we implemented as a config dictionary here, where you are able to set the exact same options that you can do directly in BigQuery. And then, of course, the nice thing is that you can use the ref function to reference your other tables, so your feature tables or your staging tables, whatever. And the model is now included in the DBT DAG. So when you open your documentation, it will actually be a node in the DAG. So you can see the entire lineage of how this model came to be. And even if you have downstream tables that use this model, you can see that as well. Yep. So for the we also implemented a hook inspired by the event logging package that will basically run after training and grab some information about these features and training info and weights and so on. Normally you would do this in BigQuery as a select statement, then select from these different built-in tables that are created during the training process. ML training info, ML.feature info, and so on, with reference to your model. With the hook or the macro that we implemented, you can just specify a hook. Let me see, I think my slideshow froze. Oh, do you see that now? Yep. So you can just specify a hook in the config or in your dbt project.yaml file. And then it'll take care of grabbing all this data from these meta tables and log it to an audit table that you've specified as well. So this runs automatically on training, and you're able to keep an entire history of how this model evolves over time. You can then bring that back as a source in DBT and build, models on top of it and show it in your BI tool if you want. And finally, let's see. Oh, there you go. There's the predict function in BigQuery where you simply call from ml.predict and then a reference to your model, and the training data that you, or the test data or production data that you want to bring in and run through this model to get a prediction. That would usually look something like this in BigQuery, and in DBT we implemented this macro, predict macro, that you give a reference, again, so that it ties into the DAG, and then a reference to a CTE or to a table or another reference if you want. And then it'll run your model on that input data and give you back all the input columns, as well as a predicted label at the end. So this is mostly a utility function to make sure that the model is, or the downstream tables actually reference the model in the DBT DAG, and it's very nice for documentation and so on. Yep. Finally, I have some pros and cons here. What we've seen, we think it's very neat to have our entire lineage preserved. So, our ingestion has our Airflow DAG, and we can pretty much see that lineage. And we also have DBT referencing sources that we know are created by Airflow, and that's very nice documented. But then we had this part at the end where we would have ad hoc queries that build features off of MARTS tables in our DBT project, but then we bring this data out and build some kind of model and push some data back in. So this was not very, we didn't have a very good overview of this, and a lot of things could go wrong, and there was a lot of more infrastructure to maintain. Also, retraining is very easy. We already have our DBT run commands running on a schedule, so we could set these models to retrain every 30 days or whatever we wanted, using what we already use for scheduling our DBT models. And then again, yeah, fewer moving parts. Everything is sort of kept together inside BigQuery, and it's a lot easier. Anybody can almost write a machine learning model now, because if you know SQL, you can write these models. You don't have to use Python or anything else. Of course, that's a possibility too. As I noted further down, we can actually build more complex models outside of BigQuery and then load them into BigQuery and then use them through DBT if we wanted to. Now, some of the cons are this, of course, doesn't improve experimentation. So it's not easier for us to, test a wide variety of parameters or anything like that. We can't do something like cross-fold validation or anything. We need to still do that outside of BigQuery, probably in Jupyter notebooks or whatever. But that's more a limitation of BigQuery ML and not so much the DBT part of it. Yeah, and then of course the built-in models are limited. We can do more. We can do different things, more things with Python scripts or whatever, at the cost of more difficult maintaining them. Finally, there's I noted there's a vendor login. If we start to put everything inside BigQuery, it'll be very hard to move to Snowflake or, God forbid, Redshift or something like that. But I think that's yeah. I put it in parentheses because we can export models and so on. We can actually also train models in BigQuery, export them, and then serve them online. So, for example, recommendation models that we use to recommend articles to users on our website, we need to have those online so that every session we can hit this model and we can get a recommendation or a list of articles back that we should show this user. We can't do that inside BigQuery. We can train the model using DBT, and then we can export it later for online inference. Yep. That was all I had prepared. Yeah, as I said, this is very conceptual and still very early days. Yeah, feel free to ask any questions, or now or any other time.
Yeah, that was incredible. Seriously, this office hours is really, really cool. I have two questions very quickly. The first one is some of the, what are some of the machine learning models that you're using? You mentioned predictions for, what recommendations for articles, or I guess, saying, is this going to be a good match for this reader? And the other question is, do you have any plans to make the Materialization open source, to share that code with the community?
Yep. So we've started out using this for classification models that we have an entire telemarketing department, and they act on different triggers. So if you're tried to purchase a subscription on our website but somehow dropped off or failed, then we might prioritize you over somebody who hasn't shown any interest in our product in the sales process. So that's something we're using it for right now. For the open source part, we're very open to that. We're sure that there are some brighter minds out there that can help us make this something solid, I think.
Cool. I'm going to nominate Jeremy from our team to potentially help with that if he has any time.
Yeah.
Okay. Any other questions?
I have a question. Maybe it's more like I was looking at this and I'm like super jealous that I'm like in Snowflake and we don't have Snowflake ML and we cannot do this because like lineage and this like loop at the end is really annoying. I was thinking like Claire or DBT people, is there anything, are you guys thinking maybe of like doing DBT-like features that would interact with like other parts like Python stuff down the line? I mean, I don't know if it has been something that has come up, because then, right, it's not just a DB, a tool that interacts with DB, but it is almost like an Airflow, but everything is in the one ecosystem. I don't know, I mean, like, but it would be cute.
Hey everybody, sorry, I've been making lunch this whole time. Yeah, it's a really good question. I think we are hesitant to have DBT do anything outside of the database that you're connecting to. And so we've mostly been waiting for like BigQuery to roll out ML features, or we have a Spark adapter now, and we'll be talking about it at Office Hours next week. So that's a technology where you can very easily make the switch from SQL-based data transformation to like Python or R for more data science workflows, and do it all in the same place. I don't think we're about to try to beat out Snowflake in terms of writing SNOSQL-based logistic regression. There is a surprising amount of, because I have like all of a statistics minor for my undergrad, and there's a surprising amount of statistics that you can do with just SQL in terms of making confidence intervals and establishing a normal distribution of your data and saying, is this two standard devs away or not? Snowflake did recently make standard or SDev a fully supported window function, so that's something to celebrate, even if you don't have ML.train just yet.
It's cool. I mean, it makes sense, right? Because it's a different, very, very different space otherwise, but it's cool. Yeah. Nice.
One thing I've done with a client in the past that was on, God forbid, Redshift, they had an external model that was running like within Redshift, like it was, querying data and then transforming it in Python and putting it back into a table. And we just hacked it. We like created this extra node so that we could like observe the lineage somehow. It didn't like, the node was like a commented out ref other thing, so that we could see like, okay, this is like this machine learning model depends on these other models. And so that way we didn't create these cyclic dependencies, because you could imagine like a machine learning model used to predict customer lifetime value, which you accidentally feed into like the customers table, which you then use to predict customer lifetime value, creating these loops. So we just did that. We like created a dummy node essentially to just have a thing to represent that like this data comes from, this table comes from a machine learning process.
Right. Yeah. Actually, that's really, yeah, that's a nice little, yeah, because actually a lot of it is like, well, if you're able to like write back to the database and you don't really worry about like, you have the engineering capacity to do it, that's fine. But it is always like that really annoying thing where you have all this beautiful like documentation going along, and then you're like, oh, and it goes into the black box.
Yeah.
And you don't know where it goes back. And people are like, so what goes into this, right? And then you have to answer those questions.
Yeah.
But,
so
yeah, cool.
We didn't really like select from that model at all.
Yeah, obviously, right.
If it wouldn't
Okay,
work.
yeah, maybe I'll follow up with the question. Thanks.
Cool. Any other questions on machine learning in BigQuery or in general? Okay, silence. Thank you again, Rasmus. That was incredible. I'm very jealous of the machine learning capabilities of BigQuery. So something to get excited about for those of us who aren't yet using BigQuery. And as I said, we usually leave time just at the end to ask any questions, particularly if people are asking questions about BigQuery and DBT. We have a room full of experts, I think, on this office hours. So Mitch, I saw that you asked a question, or Mitch also asked a question about insert overwrite incremental models. I'm not sure if there's any extra questions you wanted to ask about that. But yeah, over to the room.
Yeah, I just wanted to know kind of like what people's experiences have been so far with it. It's like a decent change to make in terms of like, you got to change a lot of the config areas in the top of the model. So just wanted to kind of know what people's experiences were and what kind of value they saw out of making that switch.
I mentioned earlier that we started using it in one model. I had worked with Jeremy early on because we tested it and didn't see any benefit originally on BigQuery, and it was very, very confusing, and we sort of found that BigQuery under the hood does a lot of really good optimization already on the regular merge. But then Josh Peng, who I mentioned, did a lot of work on that for one of our really big event tables, like these massive tables with tons of JSON in it, and he ended up finding that on the instead of using merge, instant override there had a huge benefit. And so I think the takeaway is that you have to, like, I wouldn't necessarily change everything to instant override right away, but if you're having some issues with merges, really long merges on your bigger tables, it's definitely something to try out, and then the benefit can be huge.
Nice. And are you using this at all also to deal with like data lags potentially? So like if you're doing like rolling like counts over time periods, or maybe like there may be stale data that isn't verified until after a certain amount of time, like that's kind of where we're looking to potentially leverage it, is more so for efficiency costs, and then also just for performance of like, we want to make sure the most recent data is being populated.
Yeah, we do that even for the regular merges. So I mentioned earlier, we do incrementals on these large tables by not looking at just the high watermark, but going back, n number of days. We vary that, throughout the day, we do like a 2-day look back, but then we do like once a night, we do a longer 10-day look back because we have quite a bit of lag on the fact data. So you have to maybe experiment with your window there, but that works fine with the regular merge as well. Right? So as long as you have good date partitions on all your tables, and probably also a good cluster. Jeremy had a really great article on some of his findings when he was working on this instant override stuff on, like, if you at least have a cluster, one column clustered in the BigQuery table, you're already getting a lot of that benefit when BigQuery seeks those partitions. But in some cases, you can really not necessarily speed up, but save a lot of money on your incremental models using instant override. So I think he highlighted this a lot in his article as well. I wouldn't expect a speed benefit, but you definitely on some of these big tables, you can cut out gigabytes and gigabytes on your, versus a merge. But you have to experiment with it, and it takes a little bit to figure out. And so I would take like your biggest table and go with that one and see what you get out of it. I think that's true of incremental in general. We're finding that incremental models are hard. Date logic is hard. We tend to get this wrong, especially if you have a DAG full of incremental models, like incremental models reading from other incremental models. You got to be really, really careful. And so it's almost easy just to stick with your regular table until it's too expensive. and work your way in there. We tend to, because I do a lot of consulting, we tend to write everything as incremental models so people have a good template, but that's not a great approach, I think, for a new project.
Cool. Thanks a lot.
I can also chime in here. We've gone pretty much all in on the insert override strategy with static partitions. Not so much because on big tables we also see a pretty decent improvement, cost-wise at least. But it's also a lot more transparent for us what's happening. We know that we're always overriding, last 2 days partitions or whatever. Instead of having the merge, which can be, small or large merges, we don't really know what's happening. And it's also very nice to be able to reprocess things consistently. I know you can also do that on the regular merge, but it's just a lot more syntax heavy. So I think we're very, very happy, at least with the static version of the insert override.
Yeah, I would highlight that. I think the way that Josh Ping implemented this for us is he created a macro to figure out what the right partitions are to send in versus letting the materialization figure it out. And that definitely took some of the bytes and the time out of the process. And so if you can figure out ahead of time that these are my 4 or 5 days that I'm reprocessing, he just wrote a little Ginger macro to figure it out, and that super helped. And I think the other benefit that we saw or difference is that I believe that the insert override will propagate deletes as well. And so a merge won't delete a no longer existing key out of your final table, but the insert override I think will. And so sometimes that's desired.
Right, if your source table is mutated.
Exactly.
Yep.
You no longer have that record, you just delete it out of your fact tables. And that's pretty clean. I think that's definitely a good benefit. Yeah, there's a question on slots. That's a good question. We're currently not yet on reserved slots. And so I don't know how much of that's going to change there. It's a good question to figure out there. Yeah.
Can someone, for the uninitiated, just me, just explain what a BigQuery slot is?
I think it's a little bit, and then maybe the person who asked can explain it better, but it's a little bit like sort of your reserved instance on Redshift. I think probably more like you pre-purchase credits on Snowflake.
Mm-hmm.
So rather than paying on demand, you pay a set price for, I think, a number of query slots.
Mm-hmm.
And then you're not, then you're not limited by bytes processed. You're not paying for bytes processed exactly. You're just paying for the size of the query, which I don't know that I totally have a handle on what exactly encompasses a slot. I think it's a combination of CPU and bytes processed.
Yeah.
But you're a little bit less limited by how much you're using there.
Cool. I have a question for Claus, which is not really BigQuery related, but maybe I'll just ask anyway. Claus, at KWibi, you said you built the data warehouse before you actually had data. That's a pretty unique experience. Most people are doing data the other way. They're coming into a company that's already got data and trying to clean it up. How was that experience? And would you recommend other people do it, or were there parts of it that were trickier than anticipated? And yeah, just general commentary on. It
was an incredible experience. I mean, we did have test data, right? So we had a lot of beta testers, but things like subscription data, when you're dealing with an app store, that doesn't look like it looks once you go into production, right? You have all kinds of weird stuff there. And so I think that works if you have experience with the subject matter, if you understand subscription data in general. We ended up, using a lot of experience that we had from Netflix with this sort of data to say, okay, we think we need the following fact tables. We think these are things that make sense, right? And so, and here's how we think that data is probably going to shape up. And so it was super easy to build that stuff in DBT because as long as you have a table there, right, we can sort of figure out what these models are. So that was like switching that from data flow over to DBT was a big win, being able to do that before launch. But you definitely have to have a handle on the subject matter. Being able to test these things ahead of time and setting up tests for this stuff is great, right? Because then we can say, okay, well, we think this shouldn't be null, right? So let's just put that in right away. Even though the current data might have nulls in there, right? So we let tests fail for now. We're okay with that. Using WAP was big because we can say, okay, well, when we go live, right, we have certain safeties in place that we don't publish data out that's incorrect. On the other hand, having data in Looker on day one was tremendous. We have data from an ops perspective, so the engineers can go in and look at the actual events that are coming in, all the way to getting executive dashboard on day one. I don't think everyone in the company actually understood how unusual that is, that we have a fully fledged company-wide executive dashboard, but it was totally worth it, and it was big, being able to understand this from day one and not waiting with the project.
Yeah.
But you do have to get ahead of these things, because you end up having to discover a lot of sort of instrumentation issues while you're still building your product, right? You have to say, well, we didn't instrument all of these analytic events, right? We have to fix this right away, while the company is still trying to figure out how to actually build the app, right? But you do have the advantage of getting in there early.
Yeah.
Right? And being able to, you have to be very tight with the engineering team in order to pull that off.
Cool.
In general, a good tip probably.
Yeah, sounds pretty ideal. I mean, I've come in to companies that have, like, replacing something else, which is...
Yeah, I've never done that. But I mean, you end up already having legacy stuff 4 weeks in, right? We're already dealing with tables. So, yeah. But yeah.
Cool. There's one question in the chat just around implementation of incremental models. Do you use specific start and range on incremental or data reprocessing runs?
I guess we use a dynamic range, right? So we go, we essentially say, you know, today is what day? Wednesday, is it? Nobody knows what day of the week is anymore. Today is Wednesday, we go back 2 days, right? And so we use, we don't just use full days. But you can structure this any which way you want, whatever works for you. You just have to be careful that when you're dealing with like session data, for example, you're pulling full sessions, that sort of thing. You just have to be careful with this stuff. Like I said, data logic is tricky and there's no right or wrong answer. I would say like 80% of our bugs are data math related bugs. You know.
Cool. We're just on time. I can hang around for a few more minutes if anyone wants to ask any questions, but I'll close out the official office hours here. Thank you so much to Claus and to Rasmus, 2 amazing presentations. So I really appreciate that and all the effort that you put in to preparing those presentations ahead of time. To everyone else, have a wonderful Wednesday and rest of the week. If you do want to ask a question, I'll be around for another few minutes.
Thanks for having us.
Thanks, guys.